Okay, I've taken everything off of the locomotive except the driver's side rod, main rod on the main chassis. Disregard all the brass K-4s you see in the background, all the spare parts. Those are all works in process. But for now, we'll talk about this Pennsylvania K-4 chassis. This is the most important part of the entire brass locomotive. If the wheels are out of quarter, if they're out of gauge, the side rods are not fit properly, the eccentric crank, all this makes for a bad running locomotive. What you want is a smooth running chassis or running gear. Of course, right here you have the wheels, the drivers. This is referred to as the main driver. The main driver will always have the eccentric crank on it. These are the side rods. This is the main rod here, where the main rod slide goes in with the piston shaft, goes into the cylinder, which I refer to as a steam chest, and the black arm here that it slides in is known as a crosshead. This is a reverse lever, and this is a combination rod or something. So I wanted you to know a little bit about it. All these pieces have to work, they must work in unison with no binds at all for the locomotive to be running very smooth. So I have 3 tests that I do to determine if I need to repair any of these things, and hopefully I won't have to. First, we'll do what I refer to as a track test. Now you'll notice here that the main driver has a gear in the center here. Better view of it here. Put on the track. The gearbox and motor, as I said, have been removed. I'm just going to use the pencil to push it back and forth. Now, no pressure. It should run very smooth or roll very smooth with no pressure. So far, so good. Very smooth mechanism. And I will add that this is a PFM Pacific Fast Mail K4, Pennsylvania K4. It is made by Atlas. So when you hear something as PFM/Atlas, PFM is the importer and Atlas is the builder of the locomotive. So it's running smooth here, but on the track you have a lot of room on the tire and you have room on the rail. So there's a lot of area there for traction. So if there is a small bind, it may work through that because you have some areas there that will work through it. So let's remove it from the track. Now I'm going to put it on the pad, the cutting pad. The only thing touching now, I don't have the tires touching, but just the rim here, or the lip. And of course the pad is kind of rough, so I have some traction there. And again, very smooth mechanism. No binds that I can feel through the pencil. Very smooth. That's also a very good test. Keep in mind, this locomotive was put out by PFM in 1975. So this locomotive is older, the model is older than the prototype when the prototype was actually scrapped, unless you're talking about 1361 at Horseshoe Curve. But the best test is what I call the glass test. That's take your locomotive chassis with the wheels and put it on glass. Now the glass is very smooth, so if there's a bind at all, it's going to catch on the glass because all you have is a slick glass surface in the rim of the tires, the flange. Very smooth, very quiet, no binds. So again, very fortunate in that this older locomotive has no binds in the driver's side rods at all. The main tires, the drivers I mean, are not out of quarter. So all I need to do now is disassemble it, strip the paint off, paint it, put it back together. And for my friend Tom Driggers, who always complains about having locomotives that he paints and repairs a lot of issues, if he only takes in good quality locomotives to paint and repair, he won't have the problem. Hey, I appreciate y'all checking in.